Hello there, my name's Krystyna and my call sign is 2 Echo 0 Kilo Sierra Hotel, and welcome to this video presentation. I'm a member and founding chair of the Sheffield and District Wireless Society, and in this video for the foundation licence I'll be looking at module 2 under safety in amateur radio. Some of the materials that I do use for this PowerPoint presentation do come from a range of sources, including the Cheltenham Amateur Radio Society, the South Bristol Amateur Radio Club, as well as Bredhurst Receiving and Transmitting Society, otherwise known as BRATS. So much credit and much thanks to those clubs and societies for some of the materials that I've used to put this PowerPoint together. So thanks for those. One of the first things that I'll touch on in this presentation is really around the philosophy of safety in amateur radio. And as a foundation licence holder, it's just important to remain positive and to remember that amateur radio as a hobby is safe, and that we do have to treat it with respect and have a good deal of common sense. Although it can be disputed, the people that you come across don't really have that much common sense. So the one question you have to ask yourself if you don't have that common sense is to always say, do I have safety here? Am I going to be safe in what I'm doing? And once you ask yourself that question, then you'll start to get the answers and you'll realise whether you are safe or not in what you are doing. And at the foundation level, the emphasis really is about you avoiding risk to yourself, because you're not given the skills to work on live equipment. You haven't got the training there, which is something that you'll get in the intermediate and the full licence training. So ask yourself, are you going to be safe? And just to have a general awareness of what safety is about and what you need to be doing to keep yourself safe. So you need to be having an appreciation of a number of things, including the dangers of high voltages. You're working on equipment which is 230 volts from the mains power sources. You run the risk of electrocution or an electric shock, however small or however large to the point of potential for death. So you need to be asking yourself again, is what you're doing going to be safe? There's also risks of RF induction, such as on metal rings on your fingers or metal points on the watches that you may be wearing, or even around necklaces and chains and ear studs or earrings, depending on what you're wearing. You could be holding a pen which has some metal elements to it. So things like that you need to be aware of with the risks around RF induction and heating. And of course leading to the potential for RF burns, which are very unpleasant accidents should that happen to you. So these are things you need to be aware of. And finally, if you're someone that wears headphones a lot, particularly to listen out and hear for those weak stations, or particularly if you've sort of been listening to a weak station and suddenly get a loud station, you're at risk of damage to your ears because of the excessive noise and particularly the excessive headphone use. So you need to be aware of that. I'm a deaf person, I wear hearing aids, and even though I do wear them, I myself am still at risk of excessive headphone use, and I very much value having good hearing, and I certainly don't want to see my hearing loss deteriorating any further. So I do urge you to be very, very careful when it comes to wearing headphones during playing with radio. Earthing is an important point in the hobby from when you're starting off in the shack. The most important thing is to be checking around all of your equipment within the plugs and things, just to ensure that they are all safely earthed, just to prevent any earth loops within the actual shock, the actual shack. Sorry. And the most important thing is if you've got ferrite rings and what have you within the shack, you'll probably use ferrite rings on various cables, the computer cables, within the coax feeders that you've got, or even the power plugs. What kind of ferrite rings are you using? Have you got the correct one? Whether it's a clamp type, a ring type, is it of the right material? Use the internet to do some research, and when you're looking around, and look at the features of them to ensure that you are buying into the correct ferrite ring for what you want to do, so that they're fit for purpose. And there are a range of different types of ferrite rings, so use them correctly to ensure that you're properly protected within the shack. Also bear in mind that you may well sort of earth your shack and your radio, and very, very cleverly sort of got a cable out and attached to the radiator. So you may have attached sort of the wire to that, and that would give you sufficient earthing. Does it? Is the question you need to ask yourself. Are you going to be safe? I asked this, and I had to point this out for the simple reason that even though you've connected to the metal pipe, that will go out, and you would hope, to the outdoors. Well, major companies now, they are using plastic pipes for their gas and water pipes, and plastic in itself gives a very high resistance to earth. So your metal pipe from the radiator, which just goes to just about to the outside of the property, or even within the inside of the property, which is then joined on by the plastic. So you're at risk there of inappropriate earthing. So very, very important to be mindful of that as a foundation student. And also be aware that some of the house earths outside could be floating above the earth potential. So therefore, you may again not be appropriately earthed. It's also important not to mix two things, and that's the mains earth, which is you use for safety, with the RF earth, which is used for antennas. So make sure that you separate those two, the mains and the RF earths, and keep them completely separate. Do not mix them. It would be sort of unsafe to do so. And in any case, the mains earth is electrically noisy, and if you're attached to those, then you run the risk of getting that earth coming back into your shack equipment, and you'll be hearing and seeing a lot of noise on the radio frequencies that you're using. So a good thing is to not mix them. When it comes to the electrical wiring, the items that you've got, they do ought to be earthed, and the radio shack you've got ought to be protected by an RCD as an earth trip. So should anything happen, at least it will then switch off the power. So do look out for an appropriate RCD. And that only the items which have double insulation doesn't need to be earthed. So you just need to understand that if something is doubly insulated, then you don't have to earth it, but if it's not, then it needs earthing. So understand what is double insulation, and understand that the equipment you've got, is it singly earthed, and understand then what you need to do to earth. Outside here, just outside through this door, I have a power point. I've actually put all the electrical sort of power out through there, and onto there is a plug, which is attached to a radio shack, and there's a little notice on there, a little sign that quite simply says off. Should I be in this little room, this little box room that I'm in at the moment, it's a great computer system. I've got my radio shacks and my equipment in here as well. Should there be an electrical fault, and should there be no trip happen for whatever reason, then I could be sat here with a continual electric shock, and anyone coming in to find me, they will potentially see some shocks going on in here, and they will see the well, the single well outside that basically says off, and in an emergency they can switch that off. But I would hope that for myself that with the RCD we wouldn't reach that stage anyway. So you do need to be mindful that you have a good setup, that you have an off switch outside which is clearly visible. Or when you do set up your shack, do let everyone in your home know about it, perhaps even the neighbours when your family members are out, so that everyone knows exactly where it is and what it's for. So that if you are in that situation, those family members and those friends and neighbours can come in and simply switch it off because they know exactly what to do. So training them to keep you safe is doubly important. So when you have that off switch, do let everyone know what it's about and why it's there. So if you're a rescuer yourself and you see such an amateur, the last thing you want to be doing is touching that casualty, unless you are sure the power is off. Because otherwise, just as soon as you start reaching to touch that casualty, electricity is likely to arch from that person and reach you. So the circle of that electricity will grow wider, because it's reached you, it's arched over, and you are now someone who's at risk of the electric shocks, and you've increased the surface area. So do not go near to touch a casualty until you know that that power is off. Very important to remember that. So in terms of the mains plugs then, there tends to be now with modern day equipment 3 colours, which is shown on this diagram here, and that's the blue, the green and the brown. The green itself here in the middle, that's the earth wire, and it's usually a green and yellow stripe, and that's how you know that is the earth. With green, with the earth being green, I suppose that's the biggest clue. The neutral always goes into the left hand side here, and that's the blue colour, and the live is the brown colour here. That's the live wire within a plug. Most important thing with a plug is to avoid whiskers and trapped wires, and to ensure that the cord grip here is secure. But try not to pierce that insulation, the white or the black insulation of the wire. That needs to remain intact. If it has been pierced, then obviously it's unsafe, and you'll need to discard that element and rewire the plug so that it is safe. Now the fuses within the plug, they are there really to protect your equipment, and so the low power devices must be correctly fused at either 3 amps or 5 amps. So it's not always a 13 amp fuse that you'll be using for the equipment for which you want to put power to. And the faults in themselves, should a fault happen, is not always at a short. A fault may not blow a large fuse, but they may overheat the flex here, and they may cause overheating and fires. So if you've got a large fuse in there and a fault is happening, it may not be enough to blow the fuse. So it's very, very important that you use, as I say, the correct fuse for the equipment that you're using. Otherwise you're just going to have overheating occurring. Very important. And be aware of fraying or damaged insulation on the main leads. I did get picked on a couple of years ago as a foundation licence holder because I had an extension cable, and because I'd used it for quite some time, I was happy with it, and there was no earth on it, but it was just quite simply the blue and the brown. And this electrical sort of sheathing was actually outside of the plug, and I was promptly told to repair it or discard of it, which I did. And I realised then actually that I wasn't operating safely, you know. So it's very, very important that you do these things, and that you keep your plugs and everything safe, just to keep you safe. So a good plug then, and a bad plug. Let's have a look at a couple of examples. Here we've got a good plug. Looks exciting, doesn't it? You've got here where when you look at this insulation, it's not quite fully inside, and this plastic thing which is screwed down to hold on to this is not actually going to give a very, very secure grip. Ideally, this insulation needs to be up into here, into this area, so that you know that there is a good grip. The most obvious thing is you've got bare, loose wires around, and obviously, even though this is for the neutral, still not safe. None of this should be showing, and so that is unsafe. And of course, when you're looking around up here into the earth, there's elements here which is still showing, and we're not quite sure whether that is safe. What you really need is a good arch round in this direction, so that you've got a straight insertion of this wire into here. And this is not a good example. And then furthermore, here you'll see within this brown live wire there is some loose elements of strands here. If this wire from this side was to become loose, particularly if you tripped over the wire and you pulled it, these could come loose and connect with the live wire, and that's when you'll get a good shock happening. So not a good example of a plug. Oh, furthermore, just down at the bottom, there's two other issues. This is a broken element of the plug just around here. You'll see where it's frayed and where it's been damaged and broken off. There needs to be a complete seal around the plug for maximum safety. And also, because of the way this live wire is plugged in, this fuse is not really sort of seated correctly. You'll notice how this looks different to that part of the fuse seating. So it's coming out, it's lifting out, and if that's what's happening, then you need to do that one again, just to make sure that both of these areas are seated properly within the plug. So not a particularly good plug, but a bad one. A good example would look something like this. Look how much tidier and cleaner that is. The insulation is much higher now. You've got no sign of any of the copper that's been shown. And notice how the fuse is seated correctly, because this is fitted, the correct fitting to go into here. And notice how the full earth here goes inside the plug. So in all, a good grip with nothing broken or anything, and that is a good clean fitting which maximises safety for you. So perhaps one of the things you ought to be doing is going around all your plugs in the property and just checking as to whether they are good plugs or bad plugs. And if they're bad, you need to be doing something to change them to make sure that they are safe. A useful exercise to do around the house, but one which also will raise your awareness. In terms of fuses then, in the UK we're quite common within our plugs. We have three sets of fuses, a 3 amp and a 5 amp and a 13 amp. They're the most common fuses. Though you can also get 10 amp fuses as well when you look around. And the fuse in itself is a special part of a mains plug, or really another circuit which has through those fuses has a relatively thin wire connected through it. And then which is connected to either end. And that fuse is said to blow if too much current flows through it, which makes the wire disintegrate and break down, or sometimes vaporise within the fuse. So if too much wire, and the wire could be of different thicknesses or a particular material, so if you have 4 amps of power going through on a 3 amp fuse, it will blow and break. And so on with a 5 amp and 13 amp, etc. So that's what a fuse is about, with a bit of a thin wire going through it. Now the purpose of the fuse is to blow if there is a fault in a piece of equipment, or in its connecting cable, which is causing too much current to be drawn. I'll always remember at some point, and you'll have heard of stories where people, if they haven't got a fuse, they might use a piece of tin foil or a piece of wire to use as a fuse to connect the power through it. There is very little chance of the tin foil or the actual thick piece of wire of breaking, and that is unsafe practice, and I would advise against doing that, but always use the correct fuse in the plug for the equipment that you're using. The reaction then, when the fuse actually shuts down and breaks down, is to shut down the supply to the power, and that then protects the electricity supply. And the secondary element then of the fuse is to try and reduce damage to the equipment and to the supply cable, and really to prevent a fire. Down here is an example of an MFJ DC power outlet, where there's various fuses that's used, very much different to the fuses in a plug, but nonetheless these are fuses with the same idea. So when you purchase equipment, commercial equipment that is made, you need to be mindful of the fuses that come with those, and to ensure that you are using the correct rating within the appropriate slots. They are there for a reason, to protect you, your equipment and your power supply. And you should always think of the fuse really that gives you that last defence against a disaster. And sure enough, it would be a disaster, so make sure I can't emphasise enough, just make sure you use the correct fuse for the purpose of the job and what it needs to do. And for you as a foundation licence, if that fuse does blow, then you need to sort out the problem. You're not trained as a foundation to understand what the problem could be, so do try and get someone else, a full licence holder from your local club, or an electrician, just to have a look at it before you reuse the commercial equipment that you've bought. Now, out of interest, not many people will know this, but do you understand, and this is not in the foundation, you're not expected to know this, but I thought I'd just add it in, just to make you understand. Just ask yourself, what's the British standard for fuses to blow? How long should it take before a fuse blows? Just think about that for a moment. What is the British standard? You might think 1,000th of a second, half a second, or perhaps half a minute, you know. And I think that would be a reasonable answer to give. In actual fact, are you aware that the British standard is that a fuse must blow within 30 minutes? Think about that for a second. If you're using equipment and there is a shock that occurs for whatever reason, that fuse, according to British standards, does not need to blow for at least 30 minutes. And that applies with a 3 amp fuse, a 5 amp fuse, 10 amp, 13 amp fuse or whatever. That's British standard. So that should emphasise a little bit more on the need to use an appropriate fuse for the equipment that you're using. Not many people know what the British standard is. It's not in the foundation, but something to raise your awareness. In terms of power supplies then, the PSU, the power supply unit, is the most common piece of equipment in the amateur radio shack, and they combine both mains and high currents within your shack. And what the power supply unit does is convert the mains 230 volts down to 13.8 volts in order to run the amateur radio equipment. That's a lot of work that it's actually doing when it's converting that down to make it appropriate for your equipment that you're using. So earthing those and protecting those is going to be very important. Now the earthing is an extra way of protecting you should your electrical equipment develop a fault for whatever reason. So imagine that a stray wire inside a piece of equipment has come loose. Just imagine for a moment that inside your equipment a bit of wire is loose. And if that wire in itself happens to be the live wire, and if that live wire then touched the casing, and that there was no earthing or earth, then the case itself that's sitting on your desk would become live as well, and you would risk electrocution, particularly if you come to touch it. Or if you just happen to have your elbow on the desk, which is connected to the live casing, the power that could arch over to you, and you could get a shock that way. So very, very important to understand how earthing, appropriately will help to protect you further from electrical shock. So to reduce that risk, all the equipment that you've got needs to have your casing earthed. Well, how do you do that? How do you earth the casing? Straightforward. There should be a lead attached to the case, usually internally. And that lead is then connected to the fused plug via the normal mains lead. To be supported with this, make sure you've got a full licence holder or an electrician to help you with this. Again, at the foundation, you just need to be aware of this, but to ensure that you seek appropriate professional help to ensure that you are properly protecting yourself and your electrical equipment, particularly in relation to whatever fault should develop. Now, if that live wire came loose and it touched the case, it would do what is called short to earth, and by doing so would blow the fuse, and then it will shut off the electrical supply to the equipment and make that safe. So an important thing to remember in terms of your power supplies and earthing them. So working inside equipment then as a foundation holder, well, remember, by all means take off the covers, but having a poke about it is likely to cause more damage than good. And that remember that the modern equipment is actually really, really complex, that even with circuit diagrams and even with pictures of the circuit boards, it's not going to be easy to see where a fault lies. As a foundation holder, you're not trained to be poking inside there. You're not trained to understand the components, such as the capacitors, which could give you a very strong electrical shock. By all means take off the cover to have a look to see if there are any clues as to any burns, such as black marks or smoke marks and dust. Once you've opened that to have a look, that's fine, but by all means, if you must risk doing more damage to your non-functioning pieces of equipment, there are various safety rules to follow. 1. Switch off the main supply unit at the socket and remove the plug from the socket before you open up the equipment. If you're someone with a family and there's a 3-year-old outside and they decide to have a little bit of fun, and you know what young children are like, they like to tinker with electrical things, or you've got an absent-minded family member who decides to switch on the power supply to the plug that you've still got plugged into the wall, you're going to get a bit of a shock. So make sure it's switched off and the plug is out from the wall before you even open up and start to look inside. But do not touch the circuitry. Again, you don't know what you're touching. There are some very powerful capacitors inside the equipment that you're looking into, and you will not be trained to understand what you're looking at and touching. The capacitors inside the equipment, they can remain charged at the mains voltage, 230 volts. you're at risk of touching that. And that's still there even after the equipment is turned off. Bear that in mind. PME, as it's commonly known as, or protective multiple earthing. What's that about? All you need to be aware of as a foundation licence holder is that in most modern electrical houses, the wiring may employ some PME, some protective multiple earthing. There's a diagram of something here with the incoming power, as you'll see with my mouse movement, some of the connectors between earth and neutral, and the actual sort of power meter, as well as the fuses. You won't see much from this, and I'm not going to explain it any further because you don't need to know. You just need to know whether PME exists in your property. But what is PME? That's a way of bonding the neutral and the earth together as a conductor to create an earth terminal. So when you look at this image down below my video bit, you'll see that from this top image, this is the section we're looking at. And what we're looking at here is the live coming through the fuse from the outside. And you'll see here from the fuse box, and also the coming from the outside and into the inside, the earth and the neutral is bonded together. That's all PME is in a nutshell. There is a specific problem here, and there are some rare fault conditions, such as a break in the neutral supply cable somewhere along the lines. And the neutral earth could be at a different potential to the earth outside as represented by the RF earth inside. So for this reason, you've got to pay particular attention to the bonding in PME installations. So take special care on those earthing arrangements to avoid risks in a PME fault situation. On the RSGB website, the Radio Society of Great Britain, there is a PME leaflet available for you to look at and have a read. For you as a foundation licence holder, it is really important for you to check if PME applies in your situation at home. You may be living in an older home which doesn't have PME. And the best way is that you need to understand that there are dangers associated with operating your radio station if RF earthing is also provided. And you can contact your local electrical supply unit, or best of all, get some advice. Seek specialist qualified advice. Employ an electrician to come along, explain to them what it is that you're doing and what you need to doing, to check that whether you've got PME or not, and that electrician will then be able to help you and advise you, and then help you and advise you in relation to earthing your equipment appropriately. All you need to be aware of, particularly for the licence, that in terms of PME, that you quite simply employ an electrician or qualified advice. Very important. So in terms of your safety indoors then, shack tidiness is important. I have to say, the amount of shacks I see, I could be rather sexist here, but I won't be, and even though I've implied it, women can tend to be a lot tidier, definitely. And a shack is sort of a man's sort of domain. It's the man's den, isn't it? And there's an awful lot of shacks, I have to say, which is really untidy, with main leads and cables all over the place. Something to be aware of, and particularly aware of trip hazards for you tripping over and falling over. A good shack needs to be tidy. You may have some clutter, but a good shack will make sure that your trip hazards are out of the way. Sorry for being sexist, but I'll just meant that in fun. And headphones. Be aware that excessive use, as I mentioned earlier, about picking out weak signals from background noise can damage your hearing, particularly if a louder noise comes on later. That's very, very important. But let me tell you a story about RF feedback as well in headphones. You are at risk of RF feedback. And I had a situation with headphones. And I sort of wasn't aware of it. Every week I was doing a contest, and by the end of the session of the contest, I realised I was developing a fault with my hearing aids because I was using a one-sided headphone. There was always this hearing aid that was breaking down, and I never thought for a moment that it was to do with RF building up in the headphone. And several visits to the hospital to look at the fault on the hearing aid, where the aid itself had short-circuited, I suddenly realised and became aware what the problem was. And in effect, I had to ensure that I'd got appropriate ferrite rings on the headphones, which, when I did that, the problem stopped arising. And something to be mindful of when you are using headphones. And I only became aware of that problem because I wear hearing aids which were becoming faulty and I couldn't hear. How many of you are wearing headphones that don't have hearing aids and not aware of a problem with RF coming up into the headset? Something to be mindful of. Also, when switching off equipment, to allow time for the power supplies to fully discharge after you've switched off, and whatever. So just be mindful of those sorts of things. And lightning, that's important. If you are aware of a thunderstorm, if you sort of did an internet search on lightning maps on a regular basis, you will be able to see from a real-time map where local lightning thunderstrikes are taking place. And if you know of poor weather in your local area, you may want to look at that and just check that out. If you know of lightning that's taking place, then do disconnect your antennas. The last thing you want is a direct contact with earth from your antenna outside into the indoors, which puts you at a serious risk of a lightning shock. Far beyond the 230 volts that you can expect to see from your mains. So if there's a lightning, switch off and unplug all of your antennas, don't leave them in. Protect your radios, of course, from static charges. That could be quite important to look at with appropriate earthing. So in terms of safety outdoors, it's very important to take care with ladders when erecting antennas. So there is a further slide on that, so I'll go through that pretty shortly. In terms of lightning, you need to be sort of paying particular attention to any antennas that you have at a very high location. You may well be living on a sort of a high-rise flat, for example, with an antenna outside, or you're one of the lucky people who've managed to get an antenna right up onto the roof. Or you may be a local amateur who is a minister to a local church. We do know one in Sheffield, and you may decide to sort of have an antenna right on the top of the church roof. Be aware that high antennas, they are much closer to the sky, therefore much closer to the lightning shock, and you need to be paying particular attention to that factor and what you need to do about it in case of lightning strikes. And the antenna elements themselves, you should not be touching the antenna elements when transmitting, and they should be mounted to avoid any accidental contact. And in terms of safety, I'll tell you another little story. From where I'm sitting, I have a little window just there to my left. And there was a time a couple of years ago that I looked through there was some workmen working, and they built a little scaffold pole just to reach onto the roof to get on. And just outside of that scaffolding tower, just a little bit further away from that, was a dipole that I'd got going, that I'd got on. And I was able to see what was going on, and I actually saw a worker climb up the scaffold tower. Didn't use ladders or anything, and I was on the radio at the time. And I had to say that I must go QRT, I must cease transmitting immediately. Because what was happening was the worker was just climbing up the tower, didn't realise what the dipole was, and actually reached his hand out to move it so he could get in and climb onto the tower. You can imagine the risk as an intermediate licence holder. What if I was transmitting up to 50 watts of power at the time when he touched the wire dipole? Needless to say, I did email the company, and I would not be lying to you when I had a knock on the door 25 minutes later from the operations director, who wanted to see exactly what had happened. And really that working team should have done a safety check. They should have been aware that there's a wire there. They should have been aware that there was a risk to themselves. And you as a foundation holder, when you're transmitting your 10 watts of power, 10 watts of power, you need to be aware that there is a risk here. And of course you would need to cease transmitting should ever you be in that situation like I was. So the antenna element shouldn't be touched, because otherwise, particularly when transmitting, because otherwise you'll get a pretty nasty shock. So do make sure that they're correctly mounted and at a distance, so that accidental contact is avoided. Try and keep clear of overhead power lines, particularly if you're using a vertical antenna or a fishing rod antenna. Try and avoid them if you've got power lines very close to your property or very close to where you are working. And avoid any snagging or coupling with telephone lines. Be mindful of that, and just be aware of your location when you consider exactly where you will place your antennas. Very important indeed. And that any feeders and antennas do need to be soundly fixed in case of being accidentally pulled, or if you have high winds, or whenever icing or bird strikes on them. They need to be secure, they need to be soundly secure, and they need to be safe when you are setting something up for the feeders and for the antennas, bearing in mind the range of particular incidents that could take place. So in terms of ladder safety then, it goes without saying that you do need to take care when you're erecting your ladders. And the correct angle is as shown in this diagram here, where at a height of 4 metres, the bottom of the ladder needs to be 1 metre out. And of course, if the ladder is at 8 metres, then the bottom of the ladder would need to be 2 metres out. It can be expressed in a 1:4 ratio, and that would be the correct way of ensuring the maximum and safest ladder placement. Try and get the ladder secured at the top, or make sure it's held at the bottom by someone, at the bottom by an adult. Someone that realises that there needs to be someone that is safely there just to keep you safe and secure. You may be attaching the ladder to a scaffolding tower. Tie it to that and make sure that is secure, and just make sure the ladders are always secure in that respect. Of course, when you're on a ladder, the whole point of the ladder is to reach up and to reach forwards onto something. The last thing you want to be doing is to be reaching to the side, for the obvious reason. If you need to reach to the side, then quite simply, it doesn't take much just to go down the ladder, move the ladder along and back up on it. What would you rather have? A broken neck, a broken back, or would you rather be safe? it goes without saying really. So if you are in a position of reaching, go down and go back up again once you've moved the ladder so that you don't have to overreach. If you've got any tools on you, try and get a tool belt or a tool bag around your waist, and that will stop any falling objects going down, particularly if you've got someone underneath holding your ladder. The last thing you want is for them to have a head injury or an eye injury or whatever. So do be mindful of that and make sure that the tools you carry are going to be safe. And of course, if you do drop that, you drop the spanner, you don't want to be going down and up again just to retrieve it. So have a good tool belt to help with the task that you are doing. And if you can, try and wear a hard hat when working at height or when other people around you are working at a height. Again, it goes without saying, but what if you fell? We know that bikers, cyclists all wear helmets, and all it takes is a fall off a bike in which to cause a serious injury to your head. What would happen if you fell off the ladder and slipped? You run the same risk with a head injury. And so wear a helmet and to keep yourself safe. Okay then, we're at the end of this presentation. So in terms of the homework then, for you to think about, certainly in your foundation handbook, try and read through pages 28 to 29. That's the relevant sections to be reading through and to be familiar with and to understand. And around the house, just to actually start having a look around your home. Have a good look round. This is really good practice for you to be aware of what's going on in your shack, what's going on around the home. And as you do so, check for untidy cables. Look behind the television. Look behind the video, the DVD player. Look within the shack that you have. Get those cables tidied, safe and secure using clippings and whatever that you need to do to ensure that they are safe everywhere in the home. Check your plugs. Take them out of the walls, unscrew them, have a look inside. Are there any frayed flexes? If there are, replace them. Are they appropriately fitted within the plug? Do they look safe, or do you need to readjust the plugs and the wiring inside to make them safe? Good practice, but you'll be thankful for it. Do your plugs have the correct fuse value? That is something worth looking at. Are you using the correct fuse for the equipment that is being plugged in? There is something called Ohm's law, where you will look at the power ratio to establish whether you're using the correct fuse. So look at the module on that under the technical basics to look at Ohm's law to help you decide on the correct fuse value. Does your home have PME, protective multiple earthing? That's something to go and check and find out. And if it does, certainly once you've got the advice of an electrician or a suitably qualified person, make sure you've checked that and make sure you've got the appropriate advice as to what you need to do to ensure you are properly earthed in the shack. And if you've got that shack, create an emergency well switch off point and let everybody know where it is and what it's for. Very important you do that as part of your homework. And then you may want to look up on the website for the Health and Safety Executive and look at the advice on ladder safety or any other safety around plugs and cables, etc. So do have a good look round. So that's the end of that presentation. I hope you've learnt a lot from that. Thanks for joining me. 73 for now. Bye bye.